So we're reviewing Unit 3 topics. And the first question, what type of correlation does the R value negative 0.99 indicate? What does that type of R value indicate? Negative 0.99. Okay, so better than my earlier math lab. More people got it right, but still not enough. These questions, when it talks about R value, in my opinion, are some of the easiest because you just have to memorize what I'm about to say. So negative 0.99. Isn't that pretty close to -1? Very close to it. So when it's close to -1 or -1 exactly, that will be your strong negative correlation. When it's -1 exactly or really close to it. Like even like negative 0.75, I'd still say it's closer to -1. Now, if it's closer to +1, would that be strong or weak? If it's close to +1? Let's do that. Strong or weak? If it's 1 or really close to 1. It's strong. And then whether it's positive or negative should match the symbol of the number. So if it's close to 1 or 1 exactly, then it's a strong positive correlation. Now, if it's 0 exactly, what type of correlation is that? Is the correlation 0? So not just weak, but if it's 0 exactly, it is. No, these will all be linear in some way. And actually, if it's zero, it might be the only one that doesn't. 0 is when there's no correlation. So then if it's closer to 0 than to 1, then it's weaker. So anything near 0 will be weak. And then of course the sign will match whether it's positive or negative, whatever the R value is. But closer to 0, the weaker it is. If it's 0 exactly, there's no correlation. Questions on that? So then say I give you another question like this and the R value is 0.25. How would you describe that? First, tell me, is it strong or weak? Weak. Because it's closer to 0 than it is to say like 1. Even if it was like 0.5 right in the middle, I'd still probably say that's a bit weaker. So it is weak, and then positive or negative? Positive, because the number itself is positive. Those are the two things that you should be describing, like when you are told to describe the correlation. Tell me, is it strong or weak? Is it positive or negative? Questions, comments, again? All right, so again, take notes as we go. That would have gone in like your correlation box because it's sorted a bit differently. But yeah, so then on to the next one. Jack is paid a set amount plus an hourly wage. Look at the table. Which linear function can we use to find his pay? Try to make it bigger. I didn't know it doesn't get much bigger. Okay, I feel like that's a big little bit. Sorry. So look at the table. which linear function can Jack use to find his k? For any value of x. I would put this in the 10 line, that's that one. Okay, so let's see. Reason why this goes in trend line of best fit is because that's normally how you would solve something like this, is when you are told what linear function, and we can use a lot of words for that. We could say linear model, line of best fit, trend line, they all are talking about the same thing. Then we're trying to find something in y equals mx plus b form that I can use to estimate any value of x. So not just what's in the table, but any value of x. They didn't tell you which is x and y, so that you have to figure out. I could tell you that x is usually time of some sort, almost always. Or it's something that is independent, that is not affected by other things. Your y is usually what depends on the x. So like your pay would depend on how many hours you work and not the other way around. Okay, so there's that. How do you, or how would you guys, if you were taking a test, because this was actually on your quiz earlier, would you make a scatter plot and then try drawing the line and estimating slope and y-intercept? Or would you use technology to find this answer? Technology, I would agree, because one, I don't think you guys normally carry around graph paper or know how to necessarily make a scatter plot yourself. And two, why even bother when something else is like really accurate? Like Desmos would probably be the easiest way. And I did see some people doing that just now, so that's good. How do I use Desmos to solve questions like that? What do I need to put in? Like, how would I use Desmos?
Oh, you insert the chart and then put all the numbers that were in the problem in the chart.
Okay, good. So you insert a table, and this is how, in case you guys forgot, add item right here where my mouse is, and then table. And then you copy down what your X's were, which if I remember correctly were these numbers. I'll double check. And then my Y's were, let's see, 18, 23, 28, 33, 38. So like if it were me, I'd probably copy the table on my scratch paper and then transfer it into Desmos. And then, so we put in our table. If you zoom this way, you can actually see the dots. So it makes a scatter plot. How can I make it put the line of best fit on here? Okay, perfect. So it's just like y equals mx plus b, but of course, instead of an equal sign, we use that symbol. It's like a little squiggly. I'm sure there's like a formal name for it, but I don't know it. And then, yeah, those are the buttons you press. Y1 squiggly line, mx1 plus b. And it tells you lots of things. Like it even tells you that R value right here. So we can tell it's a strong positive correlation. But to make the linear model, you really just need your slope and your y-intercept. So your m and your b. So in that case, put it in slope-intercept form. What's my slope based on what this tells me? So let me know that you know how to read what the calculator tells you. What's going to be my slope?
Yeah.
And then that should go in front of the x then. What's my y-intercept? Just like that. And then the answer options were in something that we call function notation. I've not introduced that to you yet, but still, like, out of the 4 options, the one that looked like this should have been the most familiar. And anyway, f of x equals y. So you can replace y and put f of x, and we'll get to that a different day, but that's the answer. Questions on that? Okay, so that's what you could have done on your test. You didn't have to, I don't know what other strategy you did, but you don't have to struggle with it that much. All right, so then next one. Which is not true about trend lines, aka line of best fit? They are usually drawn on scatter plots. It should be a line drawn through the center of the data. They are linear functions. They should touch every point in the data set, which is not true about trend lines, aka line of fit. Usually, it takes a few weeks and then they give it to you. I think they have to like mail it. I don't really know. When I was in high school, we like go through it with that. And like, oh yeah, no, we did it all school. Oh, so, but I think maybe you'll get an email about it. Like when you register. Right? Right, so you're choosing which is not true about your line of fit, and then maybe go to the cover area. That's your pointer that you can okay, so yeah, green is the one that is not true. They do not need to touch every point in the data set. In fact, they don't really even have to touch any of them. It just has to be drawn through the center of the data, where the points seem to be clustered around it. If it happens to touch some, great, but it doesn't have to touch even one of them. They're always drawn on scatter plots because that's the whole point. It's like we're trying to make those scatter plots have like a pattern, like to show a pattern on them. And linear means y equals mx plus b. And that's the form that they're in. Questions on that? Right, so again, take notes as we go. Here's the next one. All right, use y equals negative 2x plus 19 to predict the y value when x equals 10. There's a table there, but you don't need the table. Use that equation to predict the y value when x equals 10. From X plus B are your trend lines, line of best fit. And the whole point that like, the whole reason they're even useful is because they help us predict things that we didn't necessarily gather in our data. So like, if you look at the data table, you didn't need it, but if you look at it, here's like the actual values that they got from something. I don't even know what the stuff is at. Notice they don't have an X value of 10. You could assume that since the Y's are going down, that it's probably gonna be something less than 1, but there's 2 answers that are less than 1 here. So regardless, like here's an even better way, instead of just guessing. When they give you the equation, it's so much easier. And also when they say predict the Y value, well then the Y should still be the unknown. When X is 10, that just means instead of X, put a 10. Anytime you plug stuff in, use parentheses. And you could put the entire right side of the equal sign in your calculator and get an answer, or just know your order of operations. So multiply before adding. What's -2 times 10? -20, and then -20 plus 19 is I think you might have put a negative on the 19 by accident. Because it should actually be what? -1. Because -20 plus 19 is -1. I think you just did -20 minus 19. All right, but anyway, that's why the answer was this. So the whole point of even creating linear models is so we can use them to predict other things that wasn't in our data, like that. If they said predict the X value when Y is this, then make sure you plug in for the Y instead. Questions on this one? Okay, so then on to the next one. All right, so is there correlation if you model the data below with a linear equation? Is there causation? And the data is visits to the library versus number of books. We do need the tables and kind of make it bigger, probably. And that's as big as it'll go. So is there correlation? Is there causation? This is visits to the library versus number of books checked out. Correlation is another word for association. You remember that from the lessons. Right, again, you can notes, I'm kind of been checking around as we go, make sure we're doing that. You don't have to write the whole question, you can just summarize the main points. Okay, so causation we haven't talked about yet, but correlation we have. So if there's a correlation between 2 variables, and it could be any 2 variables, even ones that you think would not be associated at all. What you check for to see if there's an association or correlation is like trends in the data. So for example, visits to the library would be X, books checked out would be Y. And if you're looking at any set of data and you're noticing that as the x's increase, that the y's tend to increase, then there's a correlation there. If you notice that as the x's increase, that the y's decrease, there's also a correlation there. But it can't be like both at the same time. Like if it doesn't look like they're going up or down, like no consistent pattern, then there's no correlation. So like looking at this, my x's as they're going up, what's happening with the y? Would you say that the y's are going up, down, or neither? So look at it. We're going from 12 to 5 to 6 to 8 to 9 to 11. Are they all going down? They're not all going down. They're going down like here, but nowhere else. So then that also answers like they're not all going up. So that's why in this one, you would say that there's no correlation. So there's no consistent pattern, like they're not all going up, they're not all going down. You could argue that for the most part, they're going up, but the answer for this one is there's no correlation. As far as the causation goes, causation is like 100% this caused the other thing. So does visiting the library for sure mean that you're going to check out books? No, like you could go to the library for other reasons. You could check out no books at the library and still visit it often. So that's why there's no causation in this one either. So no correlation and no causation. Usually when there's no correlation, there's no causation anyway. But causation can only be proven by like scientific studies. So for example, here's like one example I use a lot. As the temperature increases outside, so do ice cream sales, right? Because when it gets hotter, you tend to want ice cream. It doesn't mean that we don't sell any ice cream in the winter. That's just like the trend. Also, when the temperature increases, so do sunburns, right? Does anything else cause sunburns other than the sun? Right? No. So you could say that there's causation between, you know, sunburns and the temperature outside. Like the more sun you get, the more sunburns there are. But there's no causation between ice cream sales and temperature outside. Because there could be other reasons that you want ice cream in the summer other than. And then, for example, because since they both go up, ice cream sales and sunburns in summer, if we compare those two, even though that there's a correlation there, does ice cream cause sunburns? No. And then the reverse is not true either. So that there can be correlation and no causation. Causation is like very rare. It'd have to be like 100% this caused it, like nothing else. All right, time for one more, and then we'll give the winner their prize. All right, so assume Pablo works from 2:30 to 7 p.m. using this linear model to model his pay per hour. How much would he earn? I know that one time before we go over it, we'll just see. Who wins, and maybe we'll go over it tomorrow or another day. But using that linear model, 10x plus 8, how much would he earn if he works from 2:30 to 7? Okay, does anyone still need to put their answer in? I'm gonna hit next. Okay. So the winner is Joel. You can come pick your prize from this bin. I don't think he was even here for unit 3 and he outscored all of you, so everyone else do better.